All right, so now I want to give you a better idea on what's happening with sediment transport, because the sediment transport to truly understand depositional shores and really any shoreline where sediment's a player, even our local coastline, which I've made the arguments is a big player, you got to look at what's happening with the waves. And so we're going to head over to some video I took out by the Rose Canyon Fault Zone back in the time when I got out and about a little more. Want to look at what we got here. It's got this, look at what's happening in the waves. Notice the wave crests are doing a couple things here. Notice how the wave crests start out parallel to the shore, all sort of straight line. As they get close to the shore, they kind of start to become more shore parallel. What you're seeing, you also notice that the wave gets smaller and smaller, especially right there. Yeah. Meanwhile, over right here, the wave energy is actually getting a little bit more focused. Also, right there, you can see the wave crest bending, compressing some of the energy on that point. But regardless of whether the wave's compressing into something or whether it's dispersing and getting a little bit quite a bit smaller, in either case, what you see is a wave doesn't crash completely parallel to the shoreline. So, because the waves approach the beach at an angle, but approach the beach at kind of an angle here, as the wave crests approach the beach at an angle, so you're going to get a but retreat basically perpendicular to the beach face. Get this sort of interesting pattern. You get this interesting pattern where you get this kind of like, zigzag motion of the sediment particle, where it approaches at an angle to shore and then retreats perpendicular to shore. And so the net effect of this is to get a net drift of sediment from in one general direction. We call this process longshore drift. And this is the net direction. So I'm going to show you another video taken from Scripps Beach after a big tropical storm came through. I'll let you take a few minutes to decide which direction is the net direction of drift. All right, here we go. So I want you to figure out which direction is the net drift of sediment. You can see several sources of sediment in here. You can see the river. You can see the little gullies of different color sediment going in here. You notice this beautiful pattern in the distribution of the different colors of sediment. To me, this was like a magical moment being up here during this time. It was, yeah. What you're seeing is sediment drifting from left to right in the video. All right, let's see how this plays out on longer time frames. Going back to whiteboard. So we have a bunch of waves coming in like this. Going at an angle like this. Your net longshore drift direction is going to be, your net direction of drift is going to be like so. So there are a couple different sources and sinks of sediment. Primary source of sediment is rivers. A secondary one is going to be cliffs. Cliffs, the erosion of the cliffs will give you a bigger, as important source of sand in many areas. And in some areas, your sand will have quite a major portion of biological activity, either seashells or some places, other stuff. Meanwhile, things like dunes are actually removing sand from the system, and submarine canyons represent the other major sink of sediment. So what typically happens is, on a typical stretch of beach, if there is any such thing as a typical stretch beach. Well, start out, your beach will be fairly bare. Then you'll have the some sort of river or creek, and it doesn't even have to be a very big river or creek; just has to be a river or creek. You'll get quite a bit of sand. Then the continued erosion of cliffs will make your beach larger and larger and larger. And when you encounter a dune field, some of that sand is going to get blown inland. You're going to get a bit less beach by that dune field. Dune fields, that dune field represents sand that's being taken away from the beach. Then finally, you hit the submarine canyon, and whoop, game over. You've lost all your sand, and the beach down there will be below there will be bare. So you can see this pattern very vividly along Torrey Pines Beach. Torrey Pines Beach, where you're getting we start off with the Pesquitas Creek emptying into the ocean here. We're going to fly down here, and then you get the erosion of these cliffs, and that gives you an ever larger and larger beach. Until you get making Black's Beach an absolutely lovely place to spend a sunny afternoon. So finally, you get down far enough south, and you hit this Scripps Canyon. Scripps Canyon Scripps Canyon immediately removes all sand from the beach. And then you see this beautiful little Bonneville hideout, the Mushroom House, as it's called. And you have a very rocky beach from about the Mushroom House up to about the pier. Then as you get close to the pier, you're getting enough sand off these cliffs to give a nice big sandy beach. And you're getting a couple creeks here that are giving a larger and larger beach down in La Jolla shores until you hit the Marine Room. And what's at the Marine Room? This fancy, expensive restaurant right here? You have the La Jolla Submarine Canyon. And you go back to a rocky shoreline. So in the next portion of this video, now we're going to look at submerging coastlines. And yeah, should be awesome.